Hello everyone. Welcome to SHR Trinity. In our previous video, we explored zero-shot prompting. Today, we advance to the next critical technique, one-shot prompting. In this video, we will cover the foundational interview questions on one-shot prompting, explaining how providing just a single example can drastically improve a model's accuracy and format adherence. Let's get started. Before we begin, if you're looking for practical, industry-oriented training in artificial intelligence and generative AI, SHR Trinity offers a comprehensive 30-hour training program. For complete course details, check the description below. Now let's begin today's interview session. We will now begin with the first 10 questions of our one-shot prompting interview series. Moving on to our next question, what is one-shot prompting and how does it differ from zero-shot prompting?
Welcome everyone. Today, let's break down the fundamental difference between zero-shot and one-shot prompting. When you ask a language model to perform a task using zero-shot prompting, you are giving it instructions with zero examples to learn from. You are essentially relying on the model's pre-trained knowledge and hoping it understands your text prompt perfectly. One-shot prompting, on the other hand, inserts exactly one concrete input-output example right before the main task. Why is this single example so powerful? Because large language models are naturally phenomenal pattern recognition engines. When you give the model that single example, it immediately analyzes the transformation logic, tone, structural formatting, and length of your example, using it as a direct blueprint for the actual task. This creates a sweet spot in prompt engineering. It significantly increases output accuracy over zero-shot without incurring the heavy token costs associated with few-shot prompting. However, you must be careful. If your single example contradicts your instructions, the model gets confused and degrades performance. Let's look at our example. If we prompt the model with text, I bought apples and bananas - apples, bananas, we aren't just telling it to parse fruit. We are implicitly showing it to extract entities into a clean Python-style string array. When the model sees the target task next, it replicates that exact array structure seamlessly.
Moving on to our next question, in what specific scenarios would you choose one-shot prompting over zero-shot?
Let's discuss practical strategy. When should you actually choose one-shot over zero-shot in production? The primary scenario is when you require strict, deterministic formatting. While instructions like return valid JSON in zero-shot can work, models often add conversational filler such as sure, here is your JSON, before the actual payload. By introducing one-shot prompting, you provide a clear structural template that forces the model into strict compliance. Another major scenario is tone alignment. Describing a complex brand voice in plain text instructions is remarkably difficult, whereas providing a single ideal sample response communicates that nuance instantly. It's also ideal when zero-shot prompts fail to enforce negative constraints, like omitting markdown. However, keep in mind that one-shot is not a magic bullet for multi-step reasoning puzzles where complex logic needs to be demonstrated across multiple scenarios. Nevertheless, for API integration, it gives you high structural reliability at minimal token overhead. Let's walk through our concrete example. Imagine building a production pipeline where you need a raw JSON sentiment payload. In zero-shot, the model might say, the sentiment is positive. Sentiment, positive. By supplying a single one-shot example showing an input mapped strictly to sentiment, positive, the model learns to drop all conversational chatter and output only the valid JSON object required by your downstream code.
Moving on to our next question, how do you correctly format a one-shot prompt to prevent the model from confusing the example with the actual task?
A common mistake when building prompts is poor formatting that causes the model to mix up the demonstration example with the real task input. If you write your prompt as one continuous block of text, the model's attention mechanism struggles to separate where the demonstration ends and the target task begins. To prevent this, expert prompt engineers use explicit visual and structural delimiters. Delimiters like XML tags, markdown headers, or triple backticks create distinct contextual compartments. When the language model parses these boundaries, its self-attention layers treat each block as a discrete functional component, instructions, demonstration, and target input. This structure eliminates hallucinations where the model answers the example twice or blends data from the example into your real response. Let's step through the example format provided. We start with an explicit instruction tag explaining the objective. Next, we define an example_input and example_output pair inside clear tags. Finally, we supply the actual data wrapped inside actual_input. By walking through this tagged workflow, you give the LLM a clean logical flow. It reads the rule, studies the isolated blueprint, and applies the exact same transformation exclusively to the actual input tag without any cross-contamination.
Moving on to our next question, what is the primary risk of providing only one example in a prompt?
While one-shot prompting is incredibly useful, you need to understand its main vulnerability, overfitting. Because the model is given only one sample point to infer the entire rule, it might over-index on irrelevant details present in that single example. In machine learning terms, it draws a strong correlation from noise. If your example contains specific words, formatting quirks, or subtle biases, the model might assume those specific traits are mandatory requirements for every future output. To prevent this pattern bleeding, your example must be structurally identical to your target output, but semantically neutral regarding specific entity details. Let's walk through our concrete example to see how this happens in practice. Suppose you craft a prompt to summarize vehicle descriptions, and your single example maps an input text about a red car to a structured output summary. If the example overemphasizes the color red or the word car, the model might overfit to those tokens. Consequently, when you pass a new target input describing a blue bicycle, the model's output might hallucinate references to a red car simply because it anchored too heavily on the single demonstration. This is why testing semantically neutral examples is essential.
Moving on to our next question, can one-shot prompting improve the reasoning capabilities of a language model?
Class, let's explore an exciting technique, combining one-shot prompting with chain-of-thought reasoning. Can a single example make a model smarter at logic? Absolutely. If your single example merely shows a complex question followed immediately by a raw answer, the model attempts to jump directly to the final answer for the real task, often leading to calculation errors or hallucinated logic. However, if your single example explicitly demonstrates the intermediate thought process, showing the step-by-step deduction, the model will mimic that exact analytical path when processing your task. This allows you to trigger complex reasoning frameworks while spending tokens on only one example instead of 4 or 5. Let's analyze the example step by step. If we ask a model a math or logic question, rather than setting the example output to just 10, we format the example output as, first take 5, add 5, which equals 10. By explicitly walking through the intermediate computation in the example, we instruct the model's generator to produce similar step-by-step reasoning tokens before arriving at its final answer on the actual task, drastically cutting down on logical errors.
Moving on to our next question, if your one-shot prompt is still returning incorrectly formatted outputs, how would you troubleshoot it?
When troubleshooting a one-shot prompt that yields incorrectly formatted responses, you must follow a methodical diagnostic checklist. First, understand a fundamental rule of LLM behavior. Models almost always prioritize concrete examples over abstract written instructions. If your written instruction says output strictly raw JSON, but your one-shot demonstration output includes conversational text like "here is the JSON you requested," the model will imitate the conversational text every single time. It favors the pattern demonstrated over the rule stated. Therefore, troubleshooting begins by comparing your instructions against your demonstration to eliminate any contradiction. Second, check whether your structural tags or delimiters are clearly separating sections. Third, confirm that the example handles the structural edge cases expected in your task data. Let's look at the troubleshooting example in detail. Suppose your pipeline breaks because conversational text prefixes your JSON payload. You inspect the prompt and discover that your example output was written as, "Here is the JSON, status, OK." To fix this, you remove the conversational preamble entirely from the example output, leaving only the raw JSON string. Once the example is a 100% accurate representation of the target format, the model aligns perfectly.
Moving on to our next question, how does one-shot prompting affect API costs and latency compared to few-shot prompting?
Let's talk about the economic and engineering trade-offs of prompt design. In a production environment, API costs and latency are critical metrics. Few-shot prompting, which typically uses 5 to 10 examples, consumes a substantial number of input tokens on every single API call. Because LLM pricing scales directly per million tokens and latency increases with context length, long prompts slow down your time to first token and drive up cloud bills. One-shot prompting provides a balanced solution. By reducing the context footprint down to a single, meticulously crafted example, you preserve structural guidance while slashing input token counts by 60 to 80% compared to traditional few-shot implementations. Let's walk through our enterprise scenario to illustrate this impact. Imagine you operate a review categorization pipeline processing 100,000 user comments daily. If your few-shot prompt contains 10 long examples, you might be sending 1,000 input tokens per request. By optimizing that prompt into a single, high-impact one-shot example, you trim the input payload down to 250 tokens per request. Over 100,000 daily requests, that simple engineering adjustment saves millions of tokens daily, resulting in massive cost reductions and significantly faster response times for end users.
Moving on to our next question, is one-shot prompting effective for fine-tuning a model's persona or tone of voice?
When configuring a specific persona or tone of voice for an AI assistant, one-shot prompting is often superior to long instructional guides. Why? Because tone is nuanced, contextual, and difficult to capture using abstract adjectives alone. Telling a model to sound witty, professional yet approachable, and slightly energetic leaves huge room for misinterpretation. Instead, applying the core principle of show, don't tell via a one-shot example gives the model a concrete stylistic reference point. The neural network captures stylistic elements, such as vocabulary choice, sentence length, greeting style, and punctuation, and mirrors them instantly. Let's examine our persona example step by step. Instead of writing 3 paragraphs explaining how to speak like a pirate, we pass a simple target scenario. The input is help me, and the demonstration output is ahoy there matey. How can Captain AI assist your voyage today? In one single turn, the model analyzes the lexical patterns, informal greeting style, and nautical-themed persona. When the real user asks a question next, the model effortlessly adopts that identical pirate persona without requiring a massive, multi-paragraph character prompt.
Moving on to our next question, what role do input-output pairs play in one-shot prompting?
To deeply understand one-shot prompting, we must examine the mechanics of input-output pairs. An input-output pair acts as a functional equation for the model. When an LLM processes a prompt, its attention mechanism evaluates the relationship between the sample input and the sample output. It extracts the underlying rule, answering the internal question, what transformation was performed to turn input A into output B? Once that mapping is deduced, the model executes that exact functional transformation on your actual task input. If you provide an output without an input, or an input without an output, the logical chain breaks and pattern inference fails. Let's walk through our specific example step by step to see this in action. Consider the sample input apples, bananas mapped directly to the sample output fruit. What does the model learn from this single pair? First, it learns semantic classification. Individual fruits should be categorized under a high-level label. Second, it learns a formatting rule. The output label must be capitalized. When the model receives the actual input cars, bikes, it applies both learned transformation rules simultaneously, producing the expected output vehicles.
Moving on to our next question, when would you completely avoid one-shot prompting in a production application?
As an AI architect, knowing when not to use a technique is just as crucial as knowing when to use it. You should completely avoid one-shot prompting when your production task involves high variance, complex decision trees, or diverse edge cases. A single example inherently demonstrates only one operational path. If your task requires the system to route inputs into 20 different dynamic categories or handle sensitive edge cases, a single example will severely bias the model toward that specific demonstrated path, leading to systemic misclassifications across other domains. In these complex scenarios, mature system design dictates moving up to few-shot prompting, fine-tuning, or agentic workflows with retrieval-augmented generation. Let's analyze our high-risk example step by step. Imagine designing a medical triage assistant intended to classify patients' symptoms across 50 distinct medical conditions. If you provide only one example demonstrating a severe cardiac case, the model will naturally overfit to emergency cardiac indicators. When presented with mild, unrelated symptoms, that severe bias can lead the model to misdiagnose or misroute the patient. In safety-critical or high-variance environments, relying on a single example is architecturally unsafe.
Excellent. You've completed part 1 of our one-shot prompting interview series. In the next video, we'll dive deeper into using one-shot prompting to enforce strict JSON and XML outputs for API integrations. If you found this video helpful, please like, share, subscribe to SHR Trinity, and press the notification bell so you never miss our upcoming AI interview preparation videos. Thank you for watching. See you in the next video.